Hello again, algebra students. Today we're going to review some of the stuff that we did last week with parallel and perpendicular lines, just a quick review. And we're going to talk about scatter plots, which I think that you already have a basic understanding of. We just want to make sure that everyone is kind of on the same page as we're beginning this new part of the unit. So if I give you a problem like this, it says which equation represents the line that is perpendicular to the graph of y equals 3/4 x minus 1 and passes through the y-intercept of that line. Oh, hold on. I'm reading that one, but it skipped a problem. Let's do this one first. We want to go parallel on this one to this graph. Parallel lines have the same slope. The slope of this line is 2. That means that my slope is 2. After I know that, I don't care at all about the rest of that equation. Now I have a point and I have a slope. I can write my equation in point slope. However, looking at these options, since I know my slope has to be 2, I know for sure A, that has a slope of 4, and B has a slope of 4. Those two are not my answers. So if I have a point and a slope, I'm going to start with point slope form, which is this, y minus y sub 1 equals m times x minus x sub 1. So I'm going to put my ordered pair 2, 3. Remember, this is your x, this is your y. Really, these are my x sub 1 and my y sub 1. So I'll have y minus my y number equals m times x minus my x number. This is point slope, but the equations that I have are in slope-intercept form. So I would have to distribute. So I'll have y minus 3 equals 2x minus 4. And then we're going to get rid of the 3. Be careful because that's really a negative 4 right there. So I get that y equals 2x. Negative 4 plus 3 is a negative 1. So plus a negative 1 or just minus 1. That means that D is the correct answer. Now back to the one that I already read. We want to go perpendicular to this graph. The slope of this graph is 3/4. The perpendicular slope, remember that's the symbol for perpendicular, would be the opposite reciprocal, which means change the sign, so it's a negative, and flip it. So I know that I'm going to need a slope of negative 4/3, which means that it's got to be A and B. Negative 3/4 for C and D, those two don't work. It also says that I want to go through the same y-intercept of this line. The y-intercept in this case was this negative 1. So that means that my B is negative 1. So now I know my slope and I know my y-intercept. It's going to be y equals, here's my m, x, and then plus a negative 1 or just minus 1, which means A is going to be the correct answer. In this problem, it says which equation describes the line that contains the ordered pair 0, 2 and is perpendicular to the graph of y equals 3x plus 1. So again, the slope here is 3. The perpendicular slope is going to be the opposite reciprocal. Change the sign. Now that 3 is really just 3/1. So when I do the reciprocal, I get 1/3. The ordered pair 0, 2, now I could use point slope because I have a point and I have a slope. However, the ordered pair 0, 2 is actually on the y-axis. It would be here. So my B is just 2. So that means my equation is going to be y equals negative 1/3 x plus 2. B. All right, now on to the newer stuff. You have already taken a look at scatter plots in the past. Scatter plots are just these points that are graphed on an x and y coordinate plane, and we look for a correlation, a relationship, or a pattern that we can find here. So in the first one, there's a positive correlation because if I would draw a line to sort of represent all of this data, it would go like there-ish. I would want a line that's going in the same general direction as all the points, and I would want to have about the same number of points above and below the line. This is not like a video game where you want to draw a line that hits the most points. I want the the line that represents all of the points as best I can. Now, this line happens to have a positive slope, which means it's going to be a positive correlation. That means that as we increase on the axis, as we go farther to the right, we're also going farther up. Both things are positive. For the next one, we have a negative correlation because the general trend here, and remember, I'm just freehanding this, so the lines might not be perfect, but that is a downhill slope. It's a negative slope, it's a negative correlation. But again, as the x's are going forward, as we're increasing the x's, the y's are actually decreasing here. So one's going up to the right, and one's going down, which is a positive and a negative, gives me a negative. The no correlation one, it is just totally scattered all over the place. If you were doing this in some kind of a computer program and trying to force some kind of a relationship here, they might sort of be able to draw a line, but it really wouldn't be a good representation of those points because they really truly are scattered everywhere. In this problem, and yes, this is an old graph because this is from the year 2000 and 2008, this shows the average number of students per computer in this school, in Maria's school. I want to know if this is a positive correlation, negative correlation, or no correlation, and then describe what it means. So clearly this is going downhill. This is a negative correlation. What it means is, as time is going on, as we are going farther to the right, as the years are increasing, the number of students per computer is decreasing, which most likely means that they're getting more and more computers. This is before like a one-to-one initiative. They don't have laptops in 2008. For the entire school, they just have maybe computer labs, and they've gotten more computers to use. So there are fewer students per computer that need to use each one of them. Okay, so that rate is decreasing. Taking a look at this graph, mail order prescriptions that started in this graph in 1995, and this graph only goes to the year 2000, but a lot of people get prescriptions delivered right to them. The graph shows the number of mail order prescriptions, determine whether the graph shows positive correlation, negative correlation, or no correlation, and describe what the correlation is. Clearly, this is a positive correlation. This is going uphill pretty steadily. So almost in a nice linear pattern. And again, oh, that was not a very good line. That was me trying to freehand this. But you can see that this is going uphill. So that means it has to be the one with the positive correlation. And the explanation makes sense. With each year, as we go forward in time, the number of mail order prescriptions has increased. Yep, that's true. So A is the correct answer on this one. Today, you're not going to have the parallel and perpendicular stuff. I just wanted to review that with you. You're going to be doing some problems where you might have to graph a list of ordered pairs and decide from the graph what kind of a correlation it is. There are also some other questions you're going to be answering. So the worksheet that you have for today, it's actually a two-sided worksheet, and you'll have some graphs that you can use to actually graph those points. As always, the answer key is in Schoology, so make sure that you check that. And when you're all done with that, and please make sure that you're doing this practice work first. When you're done with that, make sure that you take the formative in Schoology. Let me know if you need any help.